VMware vDefense security for VCF 5.x, NTA and NDR. Um, so let's talk about today's security realities. Many places security is outdated. It has outdated technology and process and too many alerts, false positives from detection software, and listed among some of the top obstacles. Introducing visibility and enforcement of VMware NSX security or vDefense security intelligence. Uh, so we have, multi-layers here, security, analytics and management, advanced threat protection, distributed firewall, and gateway firewall. Today, we are going to focus on talking about NTA and NDR, so network detection response and network traffic analysis. Uh, so network traffic analysis, build a baseline of normal. So we want to take a baseline of your network traffic and say, hey, this is what I normally look like for 30 days. And then start detecting or abnormalities, detect an attack and techniques from identifying security-related anomalies from, your normal baseline. So some quick terminology. We have a confidence score. This is how confident we are that this event is anomalous. Our detectors are what's, goes through and looks at the traffic. And this is the same traffic that you look at for NSX intelligence, those flows that we gather for NSX intelligence and that we use for rule recommendation. We can look at those flows and start getting a baseline of what's normal and then go through and start seeing what is abnormal in your environment or when abnormal traffic happens. So then we have our events, impact score, and severity, tactics. So we rely on MITRE tactics and different techniques from MITRE framework. So NTA, we were looking for, different lateral movement techniques. So, we talk about a lot about remote desktop protocol and SSH. Let's kind of walk you through a little bit, what that looks like here in a bit, what we're looking for exactly. But we are basing everything on MITRE, tactics, and we are looking for, for privilege escalation down to exfiltration. Then, of course, there's always initial access, execution, and persistence. So network traffic analysis, how's it different? Detects anonymous network behavior everywhere in your NSX network and beyond, depending on, if you're using, bare metal or not, security intelligence features, machine learning applied in, enriched flow endpoint context collected by security intelligence. Again, going back that we're using the same enriched flow data that we get from security intelligence. Again, it's 14 different detectors today. Every hypervisor is a sensor, so we don't have to install sensors. Every hypervisor already is a sensor, and there's no need for taps, mirroring networks or re-architecting your network because of your transport nodes actually, see all the traffic within your NSX environment, and we are seeing every bit of traffic there. So a quick architectural overview, flow data comes from the ESXi host. It goes into security intelligence. We do the anomaly detector. We give you an event score, and then we do a cloud connector. This slide is a little outdated, and I apologize for that. So for NDR is now on-prem. It's no longer in the cloud. So that cloud boundary no longer exists. Just to be really clear, that the slide is slightly outdated. As of NSX, 4.2.1 and using, SSP or even the older versions of NAP for 4.2, the cloud boundary no longer exists. Network traffic analysis configuration flow, basic configuration, what it looks like. You're going to activate security intelligence. You're configure security intelligence. Configure your private IP addresses, enable your detectors, configure detector exclusions, tune individual detectors to meet the requirements of your SOC operations, and configure, L7 DFW rules, as needed for punting different packets for when we want to do DNS inspection and other things. So where we need to look at the actual packets. So where do we do that? We can go into data collection and through here and set private IP ranges. Basically, you're going to go through, underneath settings, and your private IP ranges will be set up here. And what we're looking for by default, we just use the large, RFC 1918 ranges. This way we want to, get down to the actual network ranges that you're using. Then, we want to make sure we go through data collection. And data collection is where we have, all your detector activation. You can actually click on this box right here and activate them all at once, and then go through each one and kind of, go from the out of the box settings and make them more realistic for your environment. We can configure different VMs for exclusions. So if you want to have um, your 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 boxes that are doing scanning of your environment, uh, to go through and you want to turn those off. You want to make sure that you're excluding those so that you're not seeing false positives after you've done your testing to make sure, yeah, this tool works. It's picking up, everything I'm throwing at it and saying that, and giving me accurate information. You want to then turn those off so that you don't see, testing out there. And you only want to see real events. So you can go ahead and exclude that. Or if there's other, secure VMs, use cases out there where you want to exclude different VMs. Network traffic analysis. So there's about 4 different detectors here, 5, that you can go through and tune the sensitivity, and that's your horizontal port scan, NBTS, NS poisoning and relay, network drop, remote services, and port covert scan. So you can kind of configure those from 50 to 100, down to 1. If you really want to see, a lot of noise, you can go down to 1 and it'll show you a score of 1 saying, yeah, this is, just a data point. It doesn't look, like it's something that we would consider to be, malicious. You go up to 100. 100 can be very, looks like it's something malicious. It's something that is going out there and it looks like it's, abnormal to your environment. Okay, so now once we have that up, just make sure that, for some of the detectors, we do need an L7 rule to go out, especially for anything that's DNS based. So that would be your DNS tunneling and DG activity. So picking up both these are great precursors to, understanding, what an attack may be happening. So a little bit of the UI here. We have suspicious traffic UI. This is where you're going to see different events and at different severity. So you're going to see over time where these events are, and they'll have different color coding depending on, how severe they are and where they are on these lines. Then you also, if you go below, you'll see here, hey, this is a low, it's an 8, it's an unusual traffic pattern. That could just very much just be a different traffic pattern for your network for that day. I mean, that's why it's marked as just an 8 right now. We want to, just sit and watch and see if there's anything else that corresponds with that activity that makes it look malicious. Filter based on the confidence score. So, again, you can filter out anything you want. So quite a few different ways to filter as it shows here, both on confidence, detector, impact score, tactics, techniques, and of course, VM names. And you can turn off the timeline if you'd like. And you can select, what you want to see from 1 month to 1 hour to 1 month. So the graph timeline based on configuration timeline filters. Event color based detector type. So again, you can see the little colored dots here. We have an orange, and what that does, that's a lateral movement. So depending on, what's going on, it's going to show that color on here. Of course, we'd have reserved red for an exfiltration event, kind of that most serious event, we're starting to see your data is being extracted. And then you can come down here, now showing you earlier where the number 8 is, and you can see different details. What do those details look like? You can look and you can see detect suspicious DNS traffic, and against what traffic it is looking for, the target and the source will also be captured here. You'll get your impact score, your link to the detector page, the MITRE attack technique, and of course the workloads involved, and some specific information about the detector. Filter traffic through security intelligence, of course. All right, let's talk a little bit more about the detectors. These are the 14 detectors we talked about earlier, and we'll go over just one or two of them here today, so that you understand what it looks like for what they're doing. We have data upload, download, uh, destination IP profiler, DNS tunneling, DGA, horizontal port scan, relay poisoning, NetFlow beaconing, network traffic job, port profiler, server port profiler, remote services, uncommonly used port, unusual network traffic pattern, and vertical port scan. Each one of these do take some time to learn. You want to sit and give it time to learn. So anywhere from 8 to 20 days for it to learn. And one of the things that probably takes longest is remote services. Really understanding what does it look like in your environment for remote services. We want 20 days to learn that. So when we first turn on NTA and first start using things like intelligence, waiting a little while, let it get its bearings, let it do some of the machine learning that it needs to do. We want to make sure we give those detectors time to learn. All right. So then we have, MITRE attack techniques. So again, we base everything off of MITRE, and we can go out to MITRE and you can look across all the techniques off their base webpage. So if you've never been out there, you have your tactics up top, your techniques are below. So we're going to go over, mapping detectors to MITRE attack a little bit here. We want to talk about, discovery, command control, exfiltration, lateral movement, and then of course, credential trying to steal your access. So in server profiler here, we are going to see one event here. It's a low event, and we're going to grab it, and it says, "Hey, we've seen a suspicious connection." Then the detector identifies instance where the internal host and destination connection attempts from other internal hosts on unusual port numbers. The detector performs two tasks: learning and detection. And learning task, the detector establishes your profile. So again, back to learning, we're establishing the profile. Those ports, the host typically accesses by another host. So again, we're saying, hey, this is fairly typical, or hey, in detection, after we've learned and we got through the learning period, we are saying, hey, this is unusual. Let's report that up and give it a higher confidence score because it's not something we've seen on your network before and it looks suspicious. All right, remote services. I'm going to walk you through this one because I find this one to be very important. And just from this detector alone, it's one of the few that you can actually get a fair, just from this detection that you can get a very high score of something, malicious happening on your environment. So let's talk about, a typical attack here. You got your phishing email. You open up your anomaly, email, then, it's going to want to extract data to the, command and control server. So what are we looking for? People are like, remote services. Okay, I flood my network with remote services. You should be give me red lights and show me what's going on, and tell me that there's a problem. So there's a lot of software out there that does port scanning and does other things that is very benign and typical. So what are we looking for? We're looking for that, hey, I have, number 6 here, I have, RDP open and it's been open for a while. This is a long-term RDP from an HR, user into a finance machine, any two machines. And then from there, I've opened up many other remote protocols, if it's RDP, SSH, or VNC. Then from this point, I've access into, these different VMs that have, different access to different servers. And, I'm doing reconnaissance and I'm gathering files from it. All right, this is already starting to look pretty suspicious. And, we're probably already starting to give you some decent level alerts here. But, it's probably not enough to, for the SOC maybe to investigate something to give you like an 80 or a 90 type score where it's like, I need to go look at this now. Now, what's going to really kind of trigger that is we're going to hit, we're going to go from step 6 up here to step 8, and we're going to see extracting data to the staging server. So now I'm going back and I'm copying files not to the finance user machine, but I'm actually copying that I've already keyed into and SSH'd into, but I'm copying files back to the original staging server. And I see this traffic happening, and I go, now I know we're doing data exfiltration. I'm going to give an alert to the NDR engine and say, hey, this is serious. I need somebody to look into this now. Because that last step, after they've gotten that far, is, it's going to copy over to RDP into the command server, and by that time, your data is already lost. So, we want to make sure that we're giving you a high level degree of alert, saying, "Yep, this is happening." We have seen all these different, techniques going through this multi-stage, attack, going through, saying, we've gone through different, areas, and it's multi-stage at this point. That somebody is trying to exfiltrate data to an outside source. And what does that look like, in the view of a single alert? You can see different ones in here where it will go through, and you have your attacker, next hops, and all the different hops going through, and then when it spreads out to multiple hops. So again, we are going to do visualization of all this for you guys so you can take a look at it. And then you go into the connection details and get more information. So, again, anomalous nodes, a statistical deviation from the mean. We're looking for anomalous links being used, and we want to trace out, the potential root cause by looking for potential causality between connections too. And now DGA. What is DGA? DGA, in layman's terms, is basically somebody coming through and setting up different generated domain names on a DNS server, or within your own VMs, saying, hey, I'm actually creating these bogus DNS names so that I can try to extract data from your environment. Typically, this is not, detectable by signatures. Yields are on observable patterns of network traffic, and a series of failed DNS lookups are things that we're all looking for to make this happen. So you kind of want to look at it from a flow. We're gonna do fun. You can get some training data. Supervised ML to identify DGA domains, DGA detector. So we're looking now at this, saying, hey, these names, were created, or these names are failed lookups, and they're happening in very rapid fashion. They're not correct DNS names. So, we'll report on this, and this actually gets a fairly high confidence score right off the bat, and allow you to go through and say, yeah, this looks abnormal. Then if somebody's actually trying to, we actually see traffic trying to hit these links, that actually increases the score, to saying, hey, not only are we seeing that, these were created, but we're also seeing that people are going out and trying to hit these links. Again, that looks very suspicious. At that point, it's, multiple steps, multi-stage, and we want to alert your SOC and say, hey, SOC, this is something you want to look into. So an example event, the example score 65, will show up, on here, it is saying, hey, this is, so some specific traffic going here. The following data represents domains that were likely resolved. So again, this is just resolve, they're trying to be resolving from DJ different malware, and you can start seeing, the interesting names that people use. Very technical definition of the detector, detects hosts that have performed DNS lookups that resemble those issued by DJ malware. The detector relies on the DJ model, which recognizes DJ events, uses neural network to classify, domain names that are normal, and DNS records that are answered with NSX domain are analyzed and classified using that model. And guys, this requires that L7 rule we were talking about. So we need to have L7 DNS rules on your DFW to do this. So I talked about, making sure that, in these multi-stage attacks that we really want to show you what really matters. We want to get past the outdated security and too many alerts. I want to send you high fidelity alerts. And we're going to get that through NDR. So NDR, we are going to gather all the different type of alerts that, vDefend has, from malware events to threat detection events to anomaly events. And then we're going to take those, gather them, and correlate them in NDR. We want to connect that attack chain. So remote code execution for threat detection events, different remote services, DNS tunneling happening for your anomaly events, dark side malware happening for dark side, for malware. Correlate all this together, and then we can give you a high fidelity alert. More data points, the better the alert's going to be. And that's what we're doing with NDR is we're taking all these data points, and we are looking to make sure that we are giving you a high fidelity alert saying something is happening. So within NDR, we have campaigns. So this is an intrusion, campaign. You can kind of see, the entire what's going on over a period of time, the event, the incidents, and event impact score. So again, 100 being the most dangerous detection. Typically, you're going to have multi-stage. You're going to have some kind of exfiltration starting to look like it's going to do some exfiltration if you see 100. Again, you see those high scores, 80 to 100. This is when you want to act. All right. So the overall, network detection and response, we do gather information from distributed firewall and distributed malware prevention, distributed IPS. We have our security intelligence, and then also we can gather information from gateway firewall, IDSPS, and malware prevention. So this is what it looks like. For malware prevention, we can send stuff to the sandbox in the cloud. That's still truly today a cloud sandbox where we do full emulation, and we want to be able to see, what happens when we explode that file. We're going to send those malware events out to the NDR engines. We're going to send in security intelligence events, and we are going to send IDS, IPS events so that we can correlate all these items. So campaign. So you can look at the campaign map when you're using Intelligence Assist. Go through and go and look at the campaign map, and I'll show you the map of what's going on with NDR and what that attack looks like in the flow of the traffic. Network detection and response. Again, what we are looking for here is we're looking for the flow data from the ESXi hosts. We are looking for IDS, IPS alerts, file alerts, Kafka broker, security intelligence goes to the NTA, event collector, IDS, IPS collector, file collector, and the cloud connector. The only thing in today's version that goes past the cloud boundary is those malware files to look out for NSX for malware detection. Detector groups, we have, identifies, attack waves, confirm drive-by and download, file transfer, incoming lateral movement, outgoing lateral movement are currently are the correlation rules that we have, and vulnerability scanning, anomaly event, exfiltration. So, again, exfiltration, correlates infection types, and, and network event followed by a network event that is known for exfiltrating data, file analysis events, and recent registered domain access. What does this look like? So, if you're talking about a confirmed drive by download, it identifies campaigns, where an internal workload is exposed to a successful download drive-by. The text is successful if is followed by, command 2 malware download activity and a fake AV social engineered attack or network activity towards a known sinkhole. So we're looking for known traffic by commands so that to get that malware distribution going, and correlates the lateral movement events that are followed by the infection types, RDP to workloads, B and C subsets to command and control event, originating from the workload B is identified. So again, we are looking for multi-stage, lateral movement and then exfiltration of those files as we finish building out the slides here. Get a little bit, better look at campaigns. A campaign is going to go through and show you the different, different detectors and events. Here you can see the top 5, threads from this campaign. It's a Cobalt Strike, malicious file created, malicious execution created. So again, it's going through and correlating these different events. So it's going to be the top 5 events, top 5 affected workloads, and the tactics from MITRE that go with it. Then we have, an overview, overview of the detections, and a mapping of what each one of those detections look like, going to command and control, exfiltration, and lateral movement. Malicious activity, latest detectors, and and being able to investigate and triage. Sorry. Counts current detectors and threats, pricing of the threat itself. So again, you can look, say, hey, how many tactics are going on? How many workloads am I looking at? And how many different activities am I looking at? And you'll see your latest events and detections within display and the latest detections corresponding to the impact scores. And again, this is campaign details, overview latest detectors. And we got the same heat map to kind of show you what the latest that was going on during triage. And we can continue on into investigation and, kind of get down into the meat of it and saying, hey, what time did this happen? And keep a time series of, when things happened. I want to thank you.